of those two notations for a function inside of a function, most people like this notation a lot better than this notation. But you can see both of them on tests and exams. I like the first notation better too. It really shows that the function g is inside of the function f. And both of these you would read as f of g of x. And they mean the same thing. But the idea is to see that there's one function inside of the other function. So we have, in this one, the one function is 3x plus 2. And the other function is just x cubed. So if I would write it this way, what I'm looking at is my function inside, and this is the easy one to see, is 3x plus 2. But what is happening to the function inside? It's getting cubed. So our other function is just x cubed. Yes? Could it not be? No, because g of x goes inside. So when I look at this, what does this look like? Okay? Inside is g of x, so that's the same as putting in 3x plus 2 into f. And then all f does is says whatever you put in gets cubed. That's what the function says. So this then would become whatever you put in, which is the 3x plus 2, gets cubed. I don't know if I understand what you're trying to say. G from x cubed is the part that I don't know the from part. What do you want to write it? Hmm? G in the f function. Like, I still don't know what you guys are talking about. You want to come write it? It's like, what we have, with what we have right now, the only way that we know so far how to do the derivative of this is we have two options. One, we can expand the whole thing. Okay? 3x plus 2 cubed means 3x plus 2, 3x plus 2, 3x plus 2. We could use the product rule and have a product rule inside of the product rule. We saw that before. It was a little disastrous, right? We have that 85-minute video on YouTube earlier, right? I don't think it took us that long. But where we had the product rule with the product rule within the product rule one, right? Or you could just multiply this whole thing out. All right, if I multiplied these first two together, that's not too bad. And then if I multiply those together, that's not too bad. Let's see, we'd have 24 and 12. If you multiplied it all out, didn't take too long. And we would get, with the 3 in front, 81x squared plus, with the 2 in front, 108x plus 36. And then, if you wanted to, you could factor this. And you notice that there's a 9 in common. This is y prime now. So y prime, I could take out the 9, leaving me with 9x squared plus 12x plus 4. And then you go, oh, I saw this 9x squared plus 12x plus 4 somewhere before in this question. Oh, we had it way up here when we multiplied those two together. So that's just the same as 3x plus 2 squared. So that's kind of interesting. And what the chain rule is going to do is it's going to allow us to go directly from the question to this answer right away, which is nice. But it's looking for a pattern. Okay? Now, thinking a little bit about patterns from what we've done before. When you have a power like cubed, what was the rule we did for power rules? We brought that number in front and we subtracted 1 from the exponent. If we had just done that, this is what we would have got. That's very close to the correct answer. The only difference, this has a 3 in front, this has a 9 in front. Okay? So for some reason, we need to multiply this by 3. That's what a mathematician would have done, looked at this and said, there must be something there. I don't know what it is, but maybe if I do a couple more examples, I could figure that out. So here are a bunch more examples. We won't go through them all, but imagine you did that same thing. You expanded this completely, did the derivative, and then noticed, sure enough, this one had the 5 come out in front and subtracted 1, but this one we had to multiply by 2 in order to make it work. And the next one, that one would have been really nasty to expand out completely. But you notice, sure enough, the 40 came out in front. You subtracted 1 for 39. But this one, you had to multiply everything by 6x. And so on and so forth. And you start noticing, and you start looking for a pattern. First of all, the first pattern is easy, right? The bringing the number in front and subtracting 1, that's the same as our power rule from before. So that part is easy. But how do we get this at the end? Yes? Take the 2x plus 3. Well, you could do the whole thing because the 3 itself, the derivative would be 0. You do the derivative of the inside. Same thing with this one. That's the derivative of the inside, 6x. What's the derivative of the inside? 4x cubed minus 1. And that is, do I have more examples? No. That is the chain rule. This is how you write out the chain rule. You do the derivative of the outside function, and then you multiply it by the derivative of the function that's inside. So when doing all of these ones, you sort of start on the outside and work your way in, because we'll have some questions that are chain rules within chain rules within chain rules. And we'll see what those look like.